Xenopus laevis egg extracts are useful as sources of cytoplasmic and organelle material for in vitro reconstitution of cellular events, such as nuclear assembly and nuclear protein import. Of course, before you can use egg extracts, you first need to obtain the eggs from female frogs.
Hi, my name is Marie Cross, and I'm a graduate student in Dr. Maureen Powers' lab in the Department of Cell Biology at Emory University in Atlanta, Georgia. Today we're going to show you how to obtain and dejelly eggs from mature Xenopus laevis females. This procedure includes the following steps: priming frogs for egg laying with pregnant mare serum gonadotropin, inducing egg laying with human chorionic gonadotropin, and sorting out any bad eggs or oocytes. So let's get started.
To produce eggs, mature female frogs are first primed with pregnant mare serum gonadotropin. To begin the priming procedure, prepare a tank containing 100 millimolar sodium chloride to house frogs after injection. Primed frogs should be kept at a density of approximately 1 frog per liter. Optimal egg production is maintained by housing frogs at 18 degrees Celsius. Using a 27 gauge needle attached to a 1 ml syringe, inject frogs subcutaneously into the dorsal lymph sac with 0.5 ml of 200 units per ml pregnant mare serum gonadotropin. Return primed frogs to the tank containing 100 millimolar sodium chloride. After 2 to 3 days, induce egg laying by injecting frogs with 0.5 ml of 100 units per ml human chorionic gonadotropin. Again, inject subcutaneously into the dorsal lymph sac. After injection, place each frog in 5 liters of 100 millimolar sodium chloride. It is best to put each frog in its own container, as the quality of eggs varies from frog to frog. About 16 to 22 hours after the human chorionic gonadotropin injection, remove the frog to a clean water tank and pour the eggs into a beaker. It is advisable to observe the frogs for 1 to 2 days for signs of infection at the site of injection. At this stage, a transparent jelly coat surrounds each egg, which prevents them from touching each other. To dejelly eggs, rinse eggs once in 2% L-cysteine pH 8, then continue to incubate in 100 ml of 2% L-cysteine solution per frog for approximately 5 minutes at room temperature. Gently swirl the eggs periodically. After 5 minutes, pour the cysteine solution off of the dejellied eggs and wash them 3 times in a 0.25x modified Ringer's solution to remove debris. Pour eggs into a 100 mm glass petri dish. Working under a dissecting microscope, remove the bad eggs from the petri dish with a pasture pipette. Mature Xenopus eggs have a darkly pigmented half on top and a light half on the bottom. A white, pinpoint-sized spot, indicative of oocyte maturation, should be visible in the center of a darkly pigmented hemisphere of the mature egg. A good egg is one with even, unmottled pigmentation. Anything without this white spot is an oocyte and should be removed. Any eggs that are white, enlarged, or not uniformly pigmented should also be removed. A particularly bad egg will appear as a white puffy ball with the boundary between the hemispheres entirely obscured. Wash sorted eggs 2 to 3 times by pouring egg lysis buffer on them and then carefully pouring the buffer off, minimizing the number of eggs that are spilled out. Now, eggs can be lysed and extracts can be prepared.
We've just shown you how to obtain and dejelly eggs from mature Xenopus laevis females. Be sure to check out our other 2 videos, which show you how to prepare crude egg extracts, as well as how to reconstitute in vitro nuclear assembly using fractionated egg extracts. So that's it. Thanks for watching, and good luck with your experiments.